Ever had one part of your application crash and suddenly everything goes down? Or maybe you're tired of writing spaghetti code just to connect two services. Imagine if your services could talk to each other without being tightly coupled together. Or what if they could send messages, wait their turn, and even survive failures? That's where RabbitMQ comes in. And with NestJS, it's easier than ever. Well, in this video, I'm going to show you how RabbitMQ solves real problems in microservices and how to use it step by step in NestJS. Hey friends, welcome back to Sakura Dev channel, and this is the episode 7 of our NestJS microservices course. If you're new here, my name is Vaid and I create videos about backend development, NestJS, and all things about architecture. So let's get started. So first things first, what is RabbitMQ? Well, RabbitMQ is a message broker that lets applications talk to each other through messages. Instead of services directly calling one another, they send messages to RabbitMQ, which then routes those messages to the correct service. This enables decoupled and scalable communication. So here's a question, why even bother with a message broker? Well, it helps you to decouple your services, which means that each service can work independently. This also adds fault tolerance. If a service goes down, messages can be retried or held in a queue until it's back online. And it's also great for load balancing. So now let's go over some core concept of RabbitMQ. We have producers which send messages. The consumer receives messages. Messages are held in a queue. An exchange decide how route messages to queues. Routing keys help with message targeting. So think of the RabbitMQ as a smart post office, and it knows where each message needs to go. I will review all of these concepts in our real-world microservices application later in this video. So now let's talk about how RabbitMQ works with NestJS. Well, NestJS makes working with RabbitMQ super clean. You can use decorators like event pattern to listen for specific messages and use client proxies to send messages. You can send fire and forget messages or wait for a response. NestJS handles all the underlying logics for us. Now let's talk about the real-world use cases of RabbitMQ. Well, RabbitMQ is used in real-world applications for things like processing payments, sending email notifications, updating inventory, and any task that can happen asynchronously, which means that the producer of the message does not have to wait for the response from the receiver of the message. That was the theory and introduction of the RabbitMQ, and now in the next section of this video, we'll get hands-on and build a real microservice with NestJS and RabbitMQ. So make sure to like and subscribe to the channel. This doesn't cost you anything, but means a lot to me. Thanks for your support, and let's get into the next section. In the previous episode of this course, we have created this microservice architecture, which is a simple order processing microservice with NestJS and Kafka. Now, in this episode, we are going to implement the same architecture with RabbitMQ. So here, as you can see, we have three microservices: order service, payment service, and notification service, and also an API gateway, which sits between the client apps and the microservices. So here's the scenario. The API gateway exposes a HTTP REST endpoint for creating an order. So client app calls that HTTP endpoint and the API gateway forwards it to the order service. But it does not do that directly. Instead, it forwards the message order created to the RabbitMQ exchange, and the order service reads that message from the RabbitMQ exchange. So what is an exchange in RabbitMQ? It is actually a routing mechanism. When a producer sends a message, it does not actually send it directly to a queue. It sends it to an exchange, and the exchange decides which queue should this message goes to. So here in this example, the order created message from the API gateway goes to the order queue. And this queue is listened by the order service here, and actually it receives that message from this order queue. The routing mechanism is actually abstract away by the RabbitMQ exchange. So let's get back to our scenario. After order service receive the order created message from the order queue, which is published by the API gateway, it starts processing the order. After that, the order service sends two messages to our RabbitMQ exchange. The first one is process payment, which goes to the payment queue, and the second one is order created, which is sent to the notification queue. So payment service here listens to the payment queue and receives the messages with this payment process routing key. So it reads these messages from the payment queue and start processing the payment. In the same time, notification service is listening to the notification queue for the messages with order created routing key. So it reads these messages from the notification queue, which are sent by the order service, and then send a notification email to the customer, something like your order is processing. All right. Now let's get back to the payment service. After receiving the payment process message, it starts processing that payment. After a successful payment processing, it sent a message to the notification queue with this routing key, payment succeed. So as you can see, notification service also listening for the payment succeed messages from the notification queue. So this message will be received by notification service, and the notification service also sends another email to the customer, something like your payment was successful. So this is our simple order processing scenario, and we are going to implement it with NestJS and RabbitMQ. In the next section of this video, we are going to create a monorepo with 4 microservice applications: the API gateway, order service, payment process, and notification service, and then set up RabbitMQ with these 3 queues inside it. So if you're ready, let's get hands-on and start coding. Alright guys, I open up a brand new NX monorepo which does not contain any NestJS application yet. We are going to create our NestJS microservices in this monorepo, but before doing that, let me just set up the RabbitMQ inside a Docker container. So in order to do that, I'm going to create a Docker compose file, and inside that, we're going to set up the configuration for running the RabbitMQ inside a Docker container. So in the root path of our NX monorepo, let me create a Docker compose file. So docker-compose.yaml. And then to speed up the process, I just paste the configuration for running the RabbitMQ inside the Docker container. So as you can see, we have just one services. This means that we can set up the RabbitMQ without using the Docker compose. We can just run it with the Docker command inside the terminal, but I think it is a more convenient and clear way to set up RabbitMQ. So here, as you can see, this is the name of the service, RabbitMQ, and we have set the image name. I've got it from the Docker Hub, and this actually tells Docker, use the official RabbitMQ image with the web management dashboard built in. This is actually this 3-management tag gives us. So next we have the container name, and this just sets the actual container's name to RabbitMQ instead of creating a random name for this service. Next we have the ports mapping here. We map the port 5672, our local machine, to the same port inside the Docker container, and this is for the AMQP protocol, which is used by RabbitMQ to send and receive messages. And next we map the port 15672 to the same port inside the container, and this is for using the web UI management dashboard for the RabbitMQ. Next, we have the environment variables, and the first one is the default RabbitMQ user. We just set it to guest, and second is the default password for RabbitMQ, and also we just set it to guest. So that's it with the Docker Compose file, and now let's run the Docker Compose app to run this Docker container. All right, it's done. And let me get back to the Docker Compose file. You can see here we have port 15672 for the web UI management dashboard of the RabbitMQ. So let me just go to the web browser, and here I'm going to go to the localhost and then port 15672. So let's run that. Here, as you can see, we need to provide the username and password. We just put the guest here and do the same for the password. I just put the guest here as the password and hit login. So as you can see, we are now inside the management dashboard of the RabbitMQ. So as you can see, we do not have any queues yet, but in the next section of this video, we are going to create the queues with NestJS microservices. So now let's go to the next section of this video and create our microservices. All right, so here let's start with the API gateway application. It should expose a REST API for the client app and then forward the request to the order queue of the RabbitMQ exchange. So let's create this application and implement this functionality. So I get back to the VS Code here and let me close this Docker compose file, open up the terminal. Let me create a new terminal here. We are going to create our first NestJS application inside this NX monorepo. And since this is a NX monorepo, I'm not just going to create the NestJS application with the Nest CLI. Instead, we are going to use the NX generator to do that. So NXG, name of the plugin, which is at nx/nest, and the name of the generator, which is app. This means that we are going to create a whole new NestJS application, and then we're going to provide the name of the application. It is going to be inside the apps directory, and then its name is going to be API-gateway. Okay, so let's run that. Let's go with the default option of the NX. So here, as you can see now, we have the API gateway application. So let's get back to the diagram. First, we need to create a REST endpoint for the client app. So here I go to the API gateway application and go to the app controller. And here we are going to create a post endpoint for creating the order. So let me quickly do that. I create a post endpoint, then it is accessible under /order. And then let's create a function for that. I'll name it create order. We're going to have the body with the body decorator. We get the order and we're going to set the type to NA. As I said in the previous episode, best practice here is to create a DTO for validation and type safety. But since here we are going to focus on NestJS microservices with RabbitMQ, we're not going to implement these basic functionalities inside our NestJS application. You can check it out in my NestJS full course playlist, in which I teach you all the concept of NestJS framework. So here let's focus on the NestJS microservices with RabbitMQ. So here we get the order from the client app, and then we need to pass it to the RabbitMQ exchange. So in order to do that, we need to create a client proxy for RabbitMQ. By the way, for sending messages to the RabbitMQ, we need to use client proxies. And for listening to the messages from the RabbitMQ exchange, we need to configure a microservice application which listens to the RabbitMQ exchange. I'm going to show you how you can do that in the next section of this video. But for now, this API gateway application does not listen to any message from the RabbitMQ exchange. Instead, it just needs to send messages to the RabbitMQ. So it needs to create a client proxy. So in order to do that, let me go to the app.module here. And here in the import section, we need to use the client module to register a client proxy. But before doing that, we need to install the NestJS microservices package. So in order to do that, I open up the terminal. Let me clear this up. First, we need to upgrade our NestJS version to the latest version. So in order to do that, I'm going to use NCU or npm check updates. So first, we need to install that with npm install-g. We need to globally install that, and then npm check updates. Since we have already installed this package, I'm not going to run this script. So after installing this package, I'm going to just write NCU here. It checks the package.json file, and here is the list of the packages that we can update them to the latest version. So here, as you can see, we need to run an NCU-U. So NCU-U, it will actually update the packages inside the package.json to their latest version. And now we need to just run npm I to install the latest version of the packages. All right, it's done. And now we can install the NestJS microservices package. So npm I at NestJS/microservices. Okay, it's done. Now we can use the client module to register a client proxy for RabbitMQ. So I'm going to use client module.register, and then we need to register a client proxy. So I pass a list here, and inside the list, we can register a client proxy for the RabbitMQ. So first we need to set up a name. I'm going to just set it to order service. So here I'm going to just export a constant and set it to order service RabbitMQ, and just set it to something like RabbitMQ order service. Okay. Now we can use this constant as the name for this client module. Then we need to set the transport, which I'm going to set it to transport.RabbitMQ. It is RMQ, which means that we are going to use a RabbitMQ. Next, we are going to set the options here. Inside the options, we are going to set the URLs. And inside the URLs, we need to set the address our RabbitMQ server. So it is going to be AMQP, which is the underlying protocol for sending and receiving messages by the RabbitMQ. And then we need to set the username of the RabbitMQ server. We set it as guest in our Docker Compose file. And then colon the password. Again, it is going to be guest. And the address of our RabbitMQ, it is going to be inside the localhost and then port 5672. In the Docker Compose file, we just map this port from our local machine to the container of the RabbitMQ. So every request to this port of our local machine will be redirected to the RabbitMQ container. That's why we use localhost here. And this is very important here. If you're using this NestJS application inside the Docker container instead of localhost, we need to use the RabbitMQ here because we set the container name to the RabbitMQ. So again, this is very important. If you're using this NestJS application inside the Docker container, change this localhost to the RabbitMQ, which is the name of this service inside the Docker Compose file. Otherwise, if you run your NestJS application locally, as we are going to do, we just put the localhost here. Okay. Now, in the next option, we need to set the queue. We're going to set the messages to a queue name order queue. Okay. And finally, we're going to use queue option here, and we're going to set durable to true. This option actually keep the queue after the RabbitMQ restarts. If we set it to false, after restarting the RabbitMQ, this queue will be deleted. So make sure to set it to true. Okay, so now this is the client proxy, and now we can use it inside the app controller. So in order to do that, first we need to inject that client proxy inside the constructor. So here we're going to use @inject, and then we need to provide the name of the client proxy. We just save it inside the order service RabbitMQ, and then we're going to say private read only client, and we're going to set it to client proxy. All right, now we can use this client inside this host endpoint. So in order to do that, we can just use this client .emit. Then we need to provide a routing key. It is going to be order created, and then put the order in the body of the message. Okay, now we can just return something back to the user. We're going to return an object to the client with a message inside it and say something like order sent to RabbitMQ, and then put the order after that. Now let's run this application. So nx serve API-gateway. Let's run this. All right, so it actually gives us an error with some missing packages. We need to install this package. So let me turn off the dev server, and here we need to install two packages. I just copied them from the NestJS documentation. It is AMQP lib and also AMQP connection manager. So we need to install these two packages inside our monorepo. Okay, it's done. And now let's run the application. We've got another error, and I think that is because of exporting this constant from this module. We should not do that. Instead, we are going to create a constant file here. So constant.ts, and let me export it from here. And now we can import it from that file. And also let me get back to the app controller and import this from the constant file. Now let me open up the terminal. As you can see, the application is running without any error. So now let me open up Insomnia to send a post request to the API gateway. Okay, so I open up the Insomnia, and here we are sending a request to the /API and then /order, which is actually this post endpoint inside the app controller of the API gateway. So now let me get back to the Insomnia and send the request to the /order. As you can see here, order sent to the RabbitMQ. And now let me get back to the dashboard of the RabbitMQ. You can see here now we have one queue here, and the name is order queue, and we have one message inside it. So the message is forwarded to the RabbitMQ, and inside the exchange, it is actually routed to the order queue. So now we need to create another microservice, the order service, which needs to listen to the order queue, and then it should send the messages to the payment queue and notification queue. So in the next section of this video, we are going to implement the order service. If you're ready, let's get into it. So I open up the terminal here. Let me open up a new terminal and use NX generator to create a NestJS application. So nxg at nx/nest-app. Then we're going to put it inside the apps directory, and its name is going to be order service. The order service application is created, and let me get back here to the diagram. Here, as you can see, it needs to listen to the order queue. So as I said before, we need to add a client proxy, and for listening the messages, we need to set up a microservice with the RabbitMQ channel as its transport channel. Okay, so let me get back here. So we need to go to the order service, and in order to set up a microservice which listens to the RabbitMQ, we need to use nestFactory.create microservice. So I use create microservice function here. Then we need to pass the microservice options as its generic type. Inside the function, first we need to pass the app module, and next we need to pass a config object. In the config object, we need to set the transport channel. So I set it to transport enum that comes from the NestJS microservices. I'm going to set it to RMQ, which stands for RabbitMQ. Then we need to put the options. Inside the options, we need to set the same options here. So I just copy them from the app module of the API gateway and go to the main.ts file of the order service. So paste it here. The first one is the URL of our RabbitMQ server with the username and password. We need to specify the queue. So this microservice only listens on order queue. And also we need to set the durable to true. Next, we don't need these ports here. We just need to run the app.listen. And here in the logger, we're going to say application is listening on RabbitMQ. Okay. Now we need to go to the app controller of this order service. And in order to listen for the order created messages, we need to create a message pattern. So here we're going to use message pattern, which comes from the NestJS/microservices. And then we need to put the routing key, which is order created. Okay, so why we put this to the order created? Because here in the app controller of the API gateway, we emit the messages to the order queue with this routing key, order created. So that's why here we need to have a message pattern, order created. Okay, so we need to define two things: the queue that we are going to listen to, which we have set up inside the main.ts file of the order service. We specify the queue here, order queue, and also the routing key, which is the order created inside the message pattern. So now we can just create a function for that. I'm going to name it handle order created, and then we can use the add payload for access to the payload of the message. So we're going to get the order and set its type to any. Again, we should use DTO for type safety and validation here, but this is beyond the scope of this video. In a real world application, we need to process the order here. So I'm going to just put a comment here and say simulate processing the order, and then console log a message, order service, receive new order, and put the order inside. Let me get back to the diagram here. We have completed this section. Let me run this application. So nxserve order service. Okay, let's run that. We've got an error, and that's because here we didn't save the app controller here. We do that. Let's run the application again. Okay, as soon as the application is up, we can access to the message inside the order queue, which the API gateway pushed it to the order queue. We've got this console log here, received new order with this order ID and with the user Danny. I get back to the Insomnia, you can see the name of the user was Danny. So here, as you can see, we have a failure resilient microservice. As soon as it is up, it accesses to the messages inside the queue. So now let me push another message in the Insomnia. This time the name is Melissa. Let me get back here. We've got new order with name Melissa. So that's it for sending and listening the messages with RabbitMQ inside the NestJS microservices. Let me get back here to the diagram. You can see here the order message also needs to send the messages into two queues, the payment queue and notification queue. So let's get to the VS Code and do that. As I said before, for sending messages to the RabbitMQ, we need to have client proxies. So I go to the API Gateway app module and just copy this section, which with that, we register a client module and get back here into the app module of the order service and just paste it here. Okay, so first we need to import the client module and also the transport from the NestJS microservices. And here we need to provide a name for this client proxy. This name that we provide here is only valid inside this microservice. And this is needed when we are going to inject this client proxy into our controller. So we're going to just use a name here. We can just hard code it here instead of import it from a constant. I'm going to just name it payment client. And let me get back to the diagram. So here, as you can see, it pushes two messages into different queues, payment queue and notification queue. So here in the queue, we need to provide the first queue name. It is payment queue. And for the second queue, we need to register another client proxy. So just copy that and paste it here. For the second client module, we're going to use notification client, and we just change the queue name. It's going to be notification queue. Okay. Now let me go to the app controller here, and we need to inject the client proxies for each service inside the constructor. So first I'm going to inject the payment client. Let me just get back to the app module and copy this payment client. Actually, it's a good idea to export them from a constant file. So let me just quickly do that. I'm going to create a constant.ts file and export a constant for payment client and set it to payment client. And let's do the same for the notification client. Okay. And here I'm going to set it to notification client. We have a typo here. Let's fix that and go to the app module here and use that constant payment client. And for this notification client, also use the constant notification client. Okay. Now we can go to the app controller here, and here for the inject, use payment client constant. Okay. Then private read only payment RMQ client and set its type to the client proxy. Okay. We're going to do the same for the notification client. So just use notification client here and name it notification RMQ client. Okay, here the order created message pattern. After processing the order, we're going to just emit two messages here. First, with the payment RMQ client, we're going to emit a message with this routing key, process-payment, okay, and then put the order inside it. Next, we're going to send a message with the notification RMQ client. So dot emit, and then routing key is going to be order created. Put the order after that. Okay, so payment client sends a message with this routing key to the payment queue, and notification client sent a message with this routing key to the notification queue. So let me get back to the app module of the order service. As you can see, we have two client proxy. First one send messages to the payment queue, and second one send messages to the notification queue. Okay, so now let me get back to the diagram. Now we have implemented the order service, and now let's add the payment service. It also listens to the payment queue and also sends the messages to the notification queue. So if you're ready, let's create the payment service microservice. Okay, so let me open up the terminal. Let me quickly create the payment microservice. NXG at nx/nest, then colon app. Name of the application is going to be inside the apps, and its name is going to be payment service. All right, it's done. And let's open up the payment microservice, and let's go to the main.ts file. So since it is going to listening on messages, we need to set up a microservice. So it is going to be the same as the order microservice. So I go to the main.ts file of the order microservice and copy all the code inside the main.ts file and get back here and replace the code that I've just copied from the order service main.ts file. So here we just create a microservice that is listening to the RabbitMQ channel. We provide the URL, and here we just need to specify which queue we are going to listen to. So let me get back to the diagram, the payment service listening to the payment queue. So let me just change the queue here to the payment queue. Let's save this and go to the controller. We need to create a message pattern for receiving the messages. So here I'm going to use at message pattern, and it is going to be process payment. It is actually the routing key of the message. So we are going to listen to the payment queue with this routing key, payment process. I think we have a typo here. Let me fix that in the diagram. Okay, that's good. So let's get back here. And now let's create a function for that, handle process payment. Okay, I use the payload decorator and get the order from the body of the message. We're going to use the console log and say payment service, payment in process, and pass the order. So we have an error here. Let me fix that. Its type should be of type any because we didn't define any DTO for that. Okay, now let's run the application again. All right, now let's open up the Insomnia and send a message with the user Margaret. And now let's get back to the VS Code. And here, as you can see, we have the payment in process with the user Margaret. Okay, now we need to send messages to the notification queue. So we need to use ClientProxy for that. So here I go to the app module of the order service and just copy this client module and get back to the payment service and paste it here. First, let me import the client module, and for the name of the client, let me create a constant file, ts, and let's export the constant, say notification client, and set it to something like notification client. Okay, now get back here and set the name to the notification client. Also, let me import the transport, and here we need to send the message to the notification queue. So set the queue here to notification queue. Okay, now we can go back to the app controller here and inject this client here. So I use @inject, provide the notification client constant, use private read only notification client, and set its type to ClientProxy. Okay, now we can use it here in the process payment message pattern. So I'm going to use this, the notification client, the emit, and the routing key should be payment succeed. So I'm going to say payment succeed here for the routing key. And then we need to put the order inside it. All right, now we're done with the payment service. And all we need to do here in this video is to set up the notification service, which only listens to the notification queue. It does not send any message to the RabbitMQ exchange. So if you're ready, let's put in down the last pieces of this puzzle. All right, open up the terminal and let me quickly create the last microservice, nxg at nx/nest app, and then apps/notification service. Okay, it's done. And now let's go to the main.ts file of the order service. Let's copy that and go to the notification service. So let me find that. It's here, and open up the main.ts file and just replace the code with the code from the order service main.ts file. So we create a microservice with RabbitMQ transport channel, and we just need to set the queue here to notification queue because this notification service should listen on notification queue. Okay, now I go to the app controller file here and create a message pattern for order created. So message pattern, the routing key should be order created because here, as you can see, the order service sends a message to the notification queue with the routing key order created. Also, we need to create another message pattern with payment succeed here because the payment service sends a payment succeed message to the notification queue as well. Okay, let me get back here and let's create a function for that. I'm going to name it send order created email. We're going to get the payload with the payload decorator. So I'm going to get the order here and I'm going to just console log from notification service sending order created email and put the order inside it. Okay, let's create another message pattern. This time it is going to be payment succeed. These messages are coming from the payment service. So payment succeed. Okay, and let's name the function to send payment succeed email. Okay, and I'm just here in the console log say sending payment succeed email. Let's save this and get back here in the terminal and run this microservice. So nxserve notification service. Okay, we already have a message inside the notification service with the user Margaret. So now let me go back to the Insomnia and create another order with the user Susanna. Okay, let me get back here. We have two messages here. The first one is for order created, user Susanna, and the second one, payment succeed email with the same user Susanna. So let me check it from the order microservice. In the order microservice, we've got this message, received new order with the name user Susanna. Then inside the payment microservice, we have payment in process with the user Susanna. And in the notification service, we have two messages for the user Susanna, one for order created and the other for the payment succeed email. So we have successfully implemented this simple microservice architecture with RabbitMQ in between. So as I said in the previous episode, we have implemented the same architecture with Kafka Broker. So I have a question for you. Which one do you think is better for implementing this architecture, Kafka or RabbitMQ? So yeah, that's it for this video. If you found this video helpful, please hit the like button and subscribe to the channel. It doesn't cost you anything, but it really means a lot to me. Thanks for your support and stay tuned for the next video in this series. Bye-bye.